Question 35. Right, it's estimated that 0.7% of the population of university students have rare blood disease. In a faculty of 550 such students use a Poisson approximation. Now, the only approximation we see on the S1 paper is the Poisson approximation to a binomial. So the first thing I've got here, I've got a binomial distribution. We've got 550 students, so that's n, and the probability of having a rare blood disease is 0.7%. So 0.7%. Move that decimal point back 2 places to change it to decimal, and that's equal to 0.007. So it's a binomial 550 0.007. So to change it to a Poisson approximation, what goes inside the brackets for a Poisson is the mean, and to find the mean of a binomial, it's n times p. So the mean then is n times p, that's 550 times 0.007. That's 3.85. So I'm now dealing the Poisson of 3.85. On part A, I want the probability that the number of students is exactly 4. And probability x equal to 4. So the formula, if x is a Poisson of lambda, the probability that x equals x is e to the minus lambda times lambda to the x over x factorial. So it's e to the minus 3.85 times 3.85 to the power of 4 divided by 4 factorial, and evaluating that, that's equal to 0.194804028. So the 4 decimal places 1, 2, 3, 4. Less than 5, that stays the same, so it's 0.1948. Then B, more than 2, when the probability x is more than 2. Now for a Poisson here, we've got 550 students, so more than 2 would be a lot of calculations. So we turn this round, so more than 2 is the same as 1 take away probability of x equals 0 plus the probability of x equals 1 plus the probability of x equals 2. Okay, if I draw a little distribution table just to illustrate that, that's x, probability of x equals x, 0, 1, 2, 3, 4, and it goes on. I want more than 2, so I want all those values there added together, which, because the bottom line adds up to 1, I just do 1 take away these 3 values here. So probability that x equals 0 is e to the minus 3.85 times 3.85 to the power of 0 over 0 factorial. Probability of x equals 1, just changing the 0 to a 1, and x equals 2, working those out. Over 0. This value 0.02127 moles. Change the 0 to a 1. 0.0819. Then change the 1 to a 2. One five seven seven. Okay, so I add those three values up. I've got the third one in, so I just add on the second one. And the first one. And that equals 0.260916168 and then to get more than 2 I take that answer away from 1. If I want to go minus, the 1 minus answer, I've got to type it in now. 1 take away 0.73908 into 4 decimal places. 1, 2, 3, 4. That 8 will make the 0 to 1. Okay, but wherever we see the word approximation with a Poisson, it's always changing a binomial into a Poisson, and the n times the p is the mean, which is what is the value in the brackets for my Poisson distribution.